Hi, everyone. Nice to meet you all again. I'm going to provide you with a brief intro to big data and AI. And there is a lot to cover on this topic. So definitely in this hour, we can't cover everything. So when I designed this lecture, I tried to aim for what would be useful for entrepreneurs to know at the beginning of their journey when it comes to big data and AI. And this is how I structured my lecture. Let's start. So what's on the agenda? So yes, we are going to provide an introduction to big data and AI. First, we'll start with big data. What is big data and why should we care about it? How can we mitigate risk with big data? Then we'll switch to AI. We'll provide a very short intro to AI and GenAI, the problem domains and applications in these areas, and how you can mitigate risk with GenAI, which is very relevant to entrepreneurs. And at the end, I will talk about AI tools that will make your work more effective. You're probably familiar with some of those. I hope to educate you on some new stuff that you didn't think about, to give you some ideas. So let's go. So why you should care about big data? Because I guess many of you would like to skip straight to the fun part of AI and not stall on big data. And I totally get it, but I think it's important that we'll stall for a minute on big data. First, you need to understand your data if you want to bake a strong AI into your product, because at the end of the day, AI is based on data. So you need to be very familiar with your data, your structure, and the different components of it and what you can make out of it. Second, it's very clear to me with working with small companies and also, by the way, big companies, that there is a lack of awareness to the costs involved in cloud infrastructure, both on the product aspect and in terms of engineering culture. There is also research about it from Ernst & Young and others. The article is linked here. And the bottom line is that we usually, at the beginning of the journey, we don't give enough attention to how we structure the big data, how we architect our system around that. And the decision that we make early on come and bites us later much in the journey. And as we'll see, it has huge implications and actually can kill your velocity or make you run out of money if you are not planning for this properly. But first thing first, what is big data? And what separates it from this data? There is a definition here that I received from Perplexity, and if you are not familiar with Perplexity, I'll talk about it towards the end of this session. But we are talking about extremely large and complex data sets that are characterized by high volume, velocity, and variety, which requires very strong processing systems. The data is coming from diverse sources and in ever-increasing rates. Means that the more customers or users you have, the more data that you will have in order of magnitudes. Now, the benefits of understanding big data is first that if you are familiar with your data and you understand your data, you can start making data-driven decisions. That this is something we are always aiming for. So once you understand your data, you can start baking analytical events into your product and then have aggregated data of data analytics that you can query and even build dashboards around that. And if you enforce a proper data strategy, and I will talk in a second what a data strategy is, you can increase your team velocity by a quick margin and actually make yourself a competitive edge with regard to your competition. And third, by probably understanding your big data and designing your infrastructure properly, you can significantly reduce the costs involved around that. Now, before we big data, we had mainly standalone relational SQL databases. We had plenty of on-premise installations. For example, your bookkeeping system was on your computer. We had our music player, for those who are not kids anymore, if you remember Winamp and all this stuff that were installed on your computer, and the music you purchased was installed on your device. It was not streamed from the cloud, games, etc. Storage was expensive, and the internet was used mainly for information retrieval. And I'm talking about the early 2000s. And then we started seeing web applications. We start seeing e-commerce sites, real estate sites, interactive maps, navigation software, and more. So the internet became more functional and not just for information retrieval. Storage became much more cheaper, and there was the rise of software as a service. It means that your software is not installed anymore on premise, but rather on the cloud, and users and customers are, in order to use the software, need to work with your backend. And of course, there was the rise of mobile and always connected. And again, I asked Perplexity to draw me a map of the milestones. So we can see that Amazon Web Services were launched around 2006, and global big data market reached 10 billion around the time. 90% of the world data created in the last couple of years, that was happened in 2016. And of course, the big data analytics market grows significantly. We already know that by now. But it's become quite fast growth since the beginning of 2000. What are the characteristics of big data? As we said before, it's ever growing. We have tons of stream of events keep flowing in. It could be visits, purchases, views, processed items, click, stream songs, minute watch, stuff like that. Every time event is happening in the world, it's probably documented in our systems. And it's clearly making our data sets much bigger. There is the notion of layering. In big data, you have the raw events, which we just discussed, which describe what happened in the world, but you're usually not working directly with the raw data. Usually transform it to enriched data, meaning you clean the data and you prepare tables based on that you can actually work with. And you also create aggregated data, which is accumulated numbers for each of your metrics that you can use for analytics and also for data science. And one of the obvious things in the market is that big data infrastructure is usually hosted with one of the main three cloud service providers. Could be Microsoft, Amazon, or Google, using the product Azure, AWS, and GCS. And sometimes even that's not enough, and you build on top of it, you purchase either Snowflake or Databricks as a complementary service. Now, what did they promise us, all these cloud providers, at the beginning of the journey? And if you remember, we saw that AWS started around 2006, 7, something like that. They promised us that it's going to be much cheaper, as we don't need to manage our servers anymore. We don't need to manage hardware. We don't need IT administrators anymore, and it's going to be magical. They also promised us that it's going to be much simpler. We don't need to deal with the operating system layers, and it's all self-explanatory, and it's going to be much faster. They promised that it's going to be fully transparent in terms of the cost. We know exactly what we are going to pay, how much, and what we can make prediction based on that. And it's going to be elastic, meaning that the infrastructure will automatically grow, scale up or down based on the actual traffic. So it was a good promise and a very good story. And this is why we bought it. But reality shows that this is not really the truth. Okay. It's not cheaper in any way. You pay separately for storage, processing, and bandwidth, and each of them costs you a lot. And with the introduction of AI, processing costs are skyrocketing. If you want to train your data sets and stuff like that, it's going to cost you huge amount of money. And coding mistakes cost you also a lot of money. I know a lot of cases where a programmer did honest mistake, bug. It happens to everyone, but it took everyone to notice a week or so after that they already lost $20,000 on this specific bug before it was fixed. And I saw it a lot of times, not only once. So it's definitely not cheaper. it's not simpler. The setup is very complex if you want to do it right. You need to understand what is your raw data, what is your enriched tables, how you build the aggregated layer. And yes, we don't need system administrators, but they forgot to tell us that we are going to invent two new roles. We will need DevOps and we will need data engineering if we want to get it right. And because it's not simple, many companies don't work directly with the cloud providers, but they usually work with Snowflake or Databricks, which are two very expensive products on top of your cloud provider. And because it's not simpler, you need a lot of complementary solutions that will provide you what the cloud provider don't provide you with, such as Jenkins, Logz, Datadog, and all of this monitoring infrastructure and stuff like that. It's definitely not transparent. Okay. It's quite a guess how you are going to be built on the upcoming months. Now, if you are determined, you can understand where this is going, but you need to be on top of the numbers all the time, and it's hard. Cost spikes are not reported in real time. You had a bug, there is a spike. Okay, that's fine. You'll find about it a week from now after you lost several $10,000. So it's very hard to make a cost prediction in cloud environment. And it's not totally elastic. Yes, it's very easy. With one click, you can add machines. That's very easy. But does those machines are turned off when the traffic goes down? No. If you want to be fully elastic, there is no way around it. You will need to work with your DevOps and engineering team to come and build an elastic infrastructure on top of it, where when you don't have a lot of traffic, machine will go down automatically and stuff like that. So none of this is true. And in fact, Anderson Horowitz even published research where they estimated that the 50 top public software companies, they believe that 100 billions of market value is being lost due to cloud impact on margins. Relatively, if you would run this on your own infrastructure. And there is a interesting use case from Dropbox, for example, where they decided to shift some of their infrastructure internally, and they saved millions of dollars per year. So I'm not trying to scare you. You know what I do? We're all at the beginning of your journey. So I'm trying to raise awareness, because what I've seen that the mistake starts very early on. So here are my guidelines if you want to work with big data. Okay. So the cloud providers are very good and very easy to set up at the beginning of your journey. If you want to build your MVP and get your initial customer, that's totally fine. Even the cost would probably be reasonable, but you need to have a plan for what you are going to change once you are starting to grow. Because, on our previous session, we discussed product market fit. And when you hit product market fit, and I hope all of you do, then you'll start to see exponential growth. Then you'll start to see a lot of customers. You will no longer struggle to sell your product, remember? So it starts growing and it's fascinating. It's fun. You feel so good about yourself, and just for the right reasons. Okay. But what you don't have the time to pay attention to at this stage is your infrastructure. And if you didn't plan in advance, you won't have time to do it at this stage. Now, if you do plan in advance, you need to consider offloading your heavy processing to dedicated servers. Okay, dedicated servers means that you don't have the hardware in your office. You don't need it. You don't need to host a farm server. This is not what I'm suggesting, but there are solutions where your machines are hosted on a different faraway farm, could be in the US or whatever your customers are. The hardware is being taken care of and you get full access to the machine, and the machine is yours. You're simply paying a monthly fee for this machine. For example, when I had my own startup, we worked only with dedicated servers. We list 5 machines, very strong machines, tons of memory, stuff like that. And it simply much manage all the traffic and also all the algorithms that we ran behind the scenes, costing us around $2,000 per month. If I had this infrastructure running on cloud environment, it would probably cost to $20,000 to $35,000 per month. Now, you can probably evade totally ignore the cloud provider because there are some things that they do right, and you probably have no choice but to work with them. But think out of the box. This is what entrepreneurs need to do. And think, do I really need to put everything with the cloud provider? Because with dedicated server, for example, you can abuse the processing power of the machine as much as you'd like. And this is very good for AI. Think about out of the box when you design your infrastructure. Once your team is more than 3 people, I think you need to start thinking about data strategy, and we'll talk about what it means in a second. And after each major release, monitor the cost and look for spikes, because if you won't do it, the bill will reflect it for you. And plan in advance what data you should be able to provide a quarter or a year from now, and see how your infrastructure needs to be adjusted accordingly. So when I mention data strategy, what do I mean? It means that you have guidelines and policies for how to store, govern, process, and retain each type of data that your product produces over time. More specifically, for example, how to store the data in a way which is processed effectively. For each data set, does it need to be real time or not? What are the refresh intervals? What is the retention policy? I mean, for how long you need to contain the data in each of these data sets? Who can create data sets and stop jobs? Who owns each data set? Now, if you don't have this in place, then what will happen? The developers start building up their own data sets on top of the cloud. They start managing jobs. And at some point, these jobs are not relevant anymore, but they are still running, still costing you money. And nobody remembers that these jobs are running because, again, the cloud provider doesn't have any interest to be transparent with you and make it easy for you to see everything that's going on. And we already talked about the planning phase. So you need to have a data strategy in place before you start exploding, once your team is becoming bigger, because otherwise the cost will eat your margins. Any question about big data before we're moving to AI? Cool. Now we can switch to the AI part of the session. And I guess most of you, or maybe 100% of you, already know what is AI. Okay, so it's a simulation of human intelligence in machine, programmed to think and learn like humans. And if we are looking on the evolution of AI, starting from the early 2000s, actually there was AI before, but the infrastructure was not there yet. I mean, the theoretical knowledge of AI was before the 2000. I know I read books back then explaining the neural networks and stuff like that, but simply the hardware and the infrastructure wasn't there to support it. Starting from 2000, we can see improve the machine algorithms. We see the growth of big data and cloud computing, like we already discussed, which is a very big enabler to AI because, as I said before, AI can't work without data. And there were advancements in computer vision and speech recognition. If you are looking from 2010 forward, then we start talking about deep learning, which is a revolution, which is a neural network. If you're familiar with this concept, which requires tons of processing power, and this is why it started evolving around these years. There were breaks in natural language processing that were very important and laid the foundation for what we've seen with LLMs later on. We can see AI beating humans in complex games, and there were also the emergence of GANs, which is some sort of generative AI, which produces synthesized data, which is very interesting. For example, being able to produce faces which are not belong to any real person on Earth, or given a satellite images, produce maps or stuff like that. So those are GANs, which started evolving in 2010. And of course, you're probably very familiar with what's been happening since 2020 with the large language model and a multimodal AI system, which provided a combination of text, image, and audio, and AI-generated content, which, again, you're probably very familiar with most of that. And we also started the discussion of AI ethics and safety because, to be honest, it was quite scary what we've seen, and there's still discussion going on about it. If we are talking about the different problem domains in AI, and I'm talking about AI, not yet about generative AI, then you have the classification problem. Given some unstructured data, being able to classify it properly to several predefined data sets that we agreed in advance. We have the robotics and automation. We have the regression, the ability to giving data over time to predict what will be the data in the future. Natural language processing, NLP, the ability to understand what the text is about. Reinforced learning, meaning being able to learn from trial and error. Anomaly detection, meaning going over data and understanding that there are patterns there that do not fit with the ordinary patterns. Computer vision, the ability to understand what object seen in each image and stuff like that. We have recommendation systems, the ability to recommend something to a person based on past choices or stuff like that. Clustering, the ability to understand that several posts or entities or whatever are covering the same thing and belong together. And predictive maintenance, the ability to predict malfunctions in hardware or stuff like that. Now, this is AI, not yet Gen AI. It means that we ask the AI question and the answer are mapped to predefined templates or data sets or structures that agreed in advance. Okay, for example, for computer vision, we can ask the AI what is being shown in the image. They can say, oh, there are cats, there are stuff like that. But there is no real generation of new content. It's all mapped to structured data that agreed in advance. If we are talking about the main AI milestones, we can see 2011 that IBM Watson with Jeopardy, which is similar to the trivia game in Israel. Apple releases Siri. Google releases in 2012 the neural network image recognition, which was a real breakthrough. 2014, Facebook introduces deepfake that knows how to analyze faces with 97% accuracy. I think this project involved 9 layers of neural networks. Very interesting project. If you're into this, you can read about it more. It was really revolutionary. And Google AlphaGo defeats the world Go champion. I'm not familiar with the very specific rules of the Go game, but I understand it's a complex game. And 20, DeepMind solve the protein faulting problem, which again, I understand it's a very complex problem to solve. And so those are the main AI milestones from the previous century. And then enters generative AI. And generative AI changed the game, as you know. And when we are talking about generative AI, we're talking about a subset of AI which creates original content. Could be text, images, audio, video, code, or any other forms of data in response to user prompts or requests. Okay. So we're talking about AI which can generate content. So in 2020, we can see that GPT-3 already demonstrated very advanced language skills that weren't shown before. DALL-E engine being able to create images from text descriptions. But to be honest, I wasn't very interested in this field in these years. I was like the mainstream media. Generative AI caught my attention at 2022 with the introduction of ChatGPT, which was, to me, personally, I think it was the most disruptive product since the introduction of the iPhone. This is how I see it. You may or may not agree, of course. And then we have other impressive milestones, but we started getting used to this milestone. Yeah, GPT passes bar exam, GPT excels in standardized test, or all the tests he was given, it was 90-something% more than other. There is the multimodal capabilities that a specific AI model can do more than one thing, which is very impressive, and we'll dive in some examples. And in fact, the GenAI creates an inflection point in the market. It means that it changed how people use technology before that. It's like the smartphones created an inflection point in the phone market before you had Nokia ruling the market with the introduction of the iPhone. Everything changed. And whenever an inflection point happens in the market, everything that was before become obsolete. If you are not making adjustments, you will become obsolete yourself. Problem domains in GenAI. I'm just giving you some examples. I'm not covering all of those, but if before we had regression and anomaly detection, now we have, for example, data insights. GenAI can, given data, can provide you insights about what's happening in the data. If you take NLP and reinforcement learning, you get advanced chatbots, which is GenAI. If, for example, you take classification and computer vision, then you can start generating image and video generation with the proper GenAI engine. Again, NLP, because there is a lot of stuff that you can do with NLP and the breakthrough that NLP has seen in the last few years. If you combine it with clustering and other stuff, you can start talking about advanced text composition, as we see with ChatGPT in the seminars. You can start doing research. The AI can do the research for you. And if you take, for example, robotics and automation, recommendation system, and predictive maintenance, you can start developing models that does failure prevention. And if you're talking about product, then I think taking classification, computer vision, advanced text composition, and advanced chatbots, you get a product of ChatGPT, which actually can do all of this and probably more. And this is just for fun. If you take robotics and automation, reinforced learning, advanced chatbots, and failure preventions, you can get the Terminator. Okay, to be honest, this is quite scary. I don't think we are that far from what we've seen in the Terminator movie in terms of the capabilities that we currently have in the market. Could be scary. But putting the scary thing aside, GenAI opened a lot of capabilities that we only dreamed of back then. There are many capabilities that are now just API call away. For example, NLP, the ability to analyze text, summarize it, understand what it's about, and produce text based on that or answer questions. It was a very strong barrier for many companies who wanted to provide solutions around that, which didn't necessarily involve directly text. It was part of the product, but the founders, the entrepreneurs couldn't do it because the ability to analyze text, to understand what the user is asking, was simply too complex. But now it's an API call away. Okay? There are plenty of APIs out there for GenAI. If you want, for example, to summarize text, to design a chatbot, if you want to perform data analysis, if you want to reason and inference from any text, you can use OpenAI, Vertex AI, Anthropic, or Perplexity. They all have APIs. If you want to have advanced navigation in your system, you can use MapGPT. If you want to do image generation in your application, you can use the DALL-E engine, the Midjourney, or Stable Diffusion. If you want coding systems to bake into your product, then of course you can use a Copilot, Anthropic, or OpenAI. If you want to do some music generation in your software, then you can use Hubert or Beethoven AI. There are plenty of AIs. I didn't cover all of them, of course, but there are many of them. As a result, because it's an inflection point, because a lot of stuff that couldn't be done before are now very feasible, it was reflected in the startup funding trends. In 2023, AI startup raised $42 billion across 2,500 equity, which is a lot. Generative AI dominated almost 50% of all AI funding. And just in Q2 of 2023 alone, startup raised $24 billion globally, AI startups. So there is a flood of startups around that because it's very easy to imagine an application. I went to meetups where I see entrepreneurs, and each of them had plenty of ideas what can be done now with generative AI, stuff like that. It's very easy to come up with a product that provides value around it. However, there are caveats around that, because it seems like the startup failure also increased. In 2024, it was increased by 2%. But if you are looking on the year before, where there was a very big flood of startups, we can see that there is almost 20% increase in startup failures in 2023 compared to 2022. Top reasons startup fail. The first reason here, according to CBS Insights, is that they ran out of money. But I don't think that's a true reason. This is just a symptom. So I'm ignoring this and I'm moving to the second row. There is no market need. Okay, this is true. True. Well, always the main reason why a startup failed, there was no market need for the product. Fine. But if you look on the next couple of reasons, they got outcompeted and there was a flawed business model causing for the cause of failure. That's related to GenAI, at least to my observation. I believe that GenAI actually increased the statistic of failure, and this is why you need to be careful when considering GenAI. Reason number one, as I see it, it was mentioned before that you got outcompeted. This is because you didn't have a true moat, a barrier to entry. If it's very easy to you because it's an API call away, it's also very easy for your competitors. Okay, so it's just a matter of who is doing it faster and getting more market share. The second reason is a flawed business model, as we've seen, is because you are not addressing the business risk properly. As we discussed, if you recall in the previous lecture about the business risk, I will remind you what I'm talking about in a second. But the bottom line is that solution fail to scale as more user or customers are acquired. Meaning you design a product that has value, users are coming to use it, they are actually seeing value, but you didn't prepare to scale properly. Your business model doesn't scale with the users and you're actually starting to lose money. So the business risk is, according to Marty Kagan, is whether the solution also works with the various aspects of your business. And when we are talking about GenAI and the business risk, if not properly designed, user can abuse your GenAI invocation, resulting in negative margin per user. And as more user or customers are acquired, the API you rely on may fail to respond in a timely manner because GenAI is very heavy on the processing and the resources it requires. The API simply become non-reliable at some point. If you are using GenAI APIs, the cost and terms may vary because those are offering these APIs, they are also experimenting. This is a very new industry. They still don't have a very solid business model and things are keep changing. So it could be that at some point, some of the APIs won't be available or the cost will change, completely breaking your business model and making you run out of money. So this is very dangerous. So there are three questions that you need to ask yourself to see if you are exposed to the risk of these APIs or not. The first question is what happens if the APIs are not available to you tomorrow? If the expected impact is disastrous or even just major on your business, then you are doing something wrong with addressing your business risk. The second question you need to ask yourself, how hard would it be for someone who is highly funded to compete with you? And if someone with millions in the bank can catch up with you in less than 6 to 12 months, then you don't have a true moat. So this is very dangerous. This is something you need to ask yourself. And the third question is what happens if user consistently max the usage of GenAI feature you offer them? And if your financial model breaks in this case, then you are definitely exposed to the business risk. So how we should mitigate the risk and make sure we make the most out of GenAI APIs. So those are my guidelines. First, and I may be a party pooper here, don't use GenAI APIs for your core product offering. If your core product relies on a technology which you didn't build, this is very dangerous. It happens also with Twitter at 2012 and later with Facebook. They offered API. There were a lot of entrepreneurs building around these APIs. And at some point, Twitter decided to shut down their API, Facebook also, and all these companies were just running out of business. If you offer GenAI feature via your user interface. For example, Canva offers a background removal. You have a picture, you can click on background removal. This is a GenAI feature that is offered via user interface. Then you must limit its usage per day or per hour. ChatGPT also do it with image generation. At some point, if I generate images, the chat simply tells me that I'm over my quota, even though I'm a pro user. Okay. And also Canva and similar product, this is the tactics that they are using. And you need to set up this limit or quota you need to design it in a way which will leave healthy margin, even if it's maxed by your users. And third, I know it's cool and I know it's fun, but don't offer a GenAI feature that don't really move the needle, don't deliver any true value for the user other than coolness, because this is still costing money. Even if it's not part of your core product, think about it twice. If GenAI is at the core of your product, then first, stating the obvious, you must be a domain expert on the problem domain of the AI. If your startup offers image generation capabilities, then you can take it from an OpenAI API. You need to develop something unique about it. First, you need to understand about computer vision yourself. You need to be expert on that. And then you should need to develop the technology in-house. If you're doing something with NLP, then now there are plenty of open source LLMs that you can take and take some libraries, build it in-house around your infrastructure. So you will have full control of what happens with that when you use it. And you need to bake the cost into your business model and make sure it scales with your users. Okay. As a result, you won't be vulnerable to API cost changes. You will have a true moat, and you won't go bankrupt when many users or customers join your product. It's not all bad news. You can still leverage Gen APIs in different scenarios. For example, if you want to do a quick prototyping for reducing time to market, for example, if you want to prove or refute hypothesis, if you want to build a demo or MVP, maybe even version 1, if it's not too dangerous, sure, you can use the APIs as long as you understand that you must change it later on. Okay? You can use GenAI APIs for having nice to have features. That's totally fine. And sometimes, depending on the product and stuff like that, you can use the APIs to simulate some QA for your product. Now, there are many other ways that you can leverage generative AI if you are an entrepreneur, other than making it part of your product. And I'm sure many of you already doing a lot on the list that I'm going to show. So you can use it for market research and competitive intelligence. You can use it for content creation, posting on the web or stuff like that. Ideation. There is another lecture I'm going to deliver a few weeks from now about thinking out of the box and creativity, and we'll talk about ideation more, but GenAI can definitely help you when you are stuck. When you're trying to brainstorm with someone and no one is available, then GenAI can help you with that. Or establishing thought leadership. When I'm about to post something, just to make sure that I'm not talking nonsense, I'm always running it by GenAI to make sure to do my fact checks and stuff like that. Pitches and presentation for investors. You can ask the GenAI to double check your financial models and stuff like that. You go over your presentation, give notes. Interview summaries and acquisition phase. Those are two cases that I'm going to do a drill down now into. But you can also use it to refine your website text, image generation, and A/B test of value proposition. And I'm sure many of you already doing many of the stuff here. If we drill down to interview summary technique, and I'm stalling on this because I think can be really helpful for entrepreneurs. As part of identifying your persona, you're probably going to talk to a lot of potential users. There are going to be a lot of materials that you'll need to go through and understand what's common, what's not. So here's the technique. First, make sure to record each and every meeting with an AI tool that produces an automatic transcript. There is a Chorus AI, or there are many products in the market that does it. It's very important. Do it and this is an investment that will get your money back. I assure you, you will thank me if you are not doing it already. Then you need to define a buckets or spreadsheet structure that you would like to map all the interviews into. For example, a column about systems the customer is using or whatever makes sense to you. And have several columns, explain to the AI that this is where you want everything to map into, and then you feed the transcripts to AI. You can ask the AI for general insight, which is always good because maybe they see something that you missed. But the main goal here is to ask the AI to map all these interviews into the output format. And essentially, this is a classic classification problem, turning unstructured data into structured one, which is much easier to analyze and make conclusions. Okay. So this is a technique. If you are not already doing it, do it. Another, the acquisition technique. I told you in previous lecture that I see most of the entrepreneurs struggle with the acquisition phase. If you are still not certain with your ICP and what are the messages that you can test around to get them into a sales meeting, you can definitely use the AI for having a design of your landing page. I suggest having a general design yourself, meaning a title, subtitle, stuff like that that you would like to have on your landing page. And then you duplicate the page for each suspected persona, and then you ask the AI to fill the content and the messaging for each landing phase based on the different personas and the value propositions. And you can have several versions, several creative for each of the landing pages, and then test them via a campaign. If you are not doing it already, you need to do it. Now, this is probably one of the parts that you've been waiting on, and I understand why. What I don't like about this slide is that things are changing so fast in the industry that by the time I complete this lecture, this table could be obsolete. Okay, so let's go over it, what's happening right now with the main tools, if you're not familiar with them. And I chose 4 tools here: ChatGPT version 4.0, Claude version 3.5, Perplexity, and Google Notebook LM. They all have intelligent chat. They're very impressive, but there are differences when you check the other points. If you want a web access, that meaning that the bot will get you information from the web in an efficient manner, that ChatGPT doesn't like to go and visit the web. If you force it, it will do you a favor and they will check the web. They usually check a single page, maybe 2 pages, and get back to you with an answer. But at least ChatGPT has access to the web. Currently, Claude doesn't have access to the web, which is a very big minus. Perplexity lives on the web. Everything you ask it. If you're not familiar with Perplexity, that this is a research engine. Practically, you can ask it any question that you want. It knows the web very well. It automatically picks the sources from the web to answer your question, compile them, and give you answer to your query with references to all the places that were found on the web. I like this tool very much. So Perplexity lives on the web, and everything you ask it, it will go to the web, not necessarily to a built-in training set that was built before. And Google Notebook LM, it's not a tool that I'm using often, but from my understanding, you need to give it a URL. It will visit it and it will bring you highlights from it. In terms of images, ChatGPT can do both generation and analysis of images. Claude can do it as well. And in terms of analysis, it seems to be superior to ChatGPT at the moment. Perplexity, if you force it, it can use the DALL-E engine or Stable Diffusion, but it's better to use it for analysis only, and Google Notebook, no, not using it. In terms of having a memory feature, meaning remembering the context, so you don't have to bring the context to each and every query that you are asking the bot, then ChatGPT have the memory feature, which is very strong. Claude doesn't have it yet. Perplexity have some sort of spaces, which is a bit limited, but he remembers things about you. And as far as I know, Google Notebook LM doesn't have a memory. Then ChatGPT is good. Claude is considered very good. And Perplexity can analyze text, but is not very good producing text. And Google LM Notebook doesn't have it. In terms of superpowers, and this is the interesting part, then ChatGPT should be treated as a Swift knife, which can do a lot of stuff, doesn't necessarily excel on most of the stuff, but can do almost everything. Claude is better at mimicking personas and with coding. Perplexity is very strong with research, data analysis, can function as a search engine, which is how I'm using it. Google NM, it can use a strong list of sources, can produce an automatic podcast and frequently ask questions, given sources. Bonus tools, and we don't have a lot of time, so I'll go very fast on that. Canva. Canva is not pure GenAI tool, but it has GenAI features. I use it a lot for design, creative, infographic, and presentation. Very strong product. The script, if you need video editing, there's tons of AI features built into it. It uses a very innovative approach where it assumes that video editing is a tough problem, and code editing is a much easier problem to do. So it converts all the videos to transcript. And when you edit the text of the transcript, the video is edited accordingly. Very innovative. I use it a lot. And my mind, another important product, you can see it as an Evernote plus read it later plus AI. Everything on the web, you can throw it, text you copy, the images, invoices, whatever. It automatically tags it. You can type chairs and it will get you all the images that contain chair or stuff like that. Very strong tools. My AI stack, and this is the last slide, if you're interested to see how I'm using the product for my day-to-day job. So Perplexity is my new search engine. I replaced Google. It completely changed the way I'm approaching the web and how I'm retrieving data. I also use it for research and fact-checking. GPT, when I write posts, I wanted to prove it. Question about history or evergreen stuff that I don't need the latest necessarily. And image generation. The script for video editing, repurposing of videos for YouTube, TikTok, Instagram, stuff like that. Canva for presentation, thumbnails, and general design. Claude for tactical posts where I don't need a lot of context to provide into it. And my mind for invoices, read it later, chat screenshots, random stuff that I might be looking later on. And Notebook LM, I don't actually use it for now, but I do plan to play with this podcast feature in the future. And that was my last slide. Any questions?